It is entirely possible to calculate something mathematically correctly, but still end up with a bad result. I'm talking about assumptions. If you make a bad assumption in your scientific process, you can end up with a result that's sealed with a stamp of approval of science, but at best doesn't describe the true nature of things, and at worst can cause real harm. I have a ping pong ball, and I'm going to calculate the mass of air inside of this ping pong ball. Your assignment, yes, a random person on the internet is giving you an assignment, is to list the assumptions that I'm making along the way and think about how I could do this better. My plan is to measure the diameter of the ping pong ball with calipers, and that's 37.37 millimeters. Convert that into a radius. I'm going to plug the radius into this equation to calculate the volume of a sphere. Then I'm going to use the density of atmospheric air to convert that volume into a mass. There will be some unit conversions along the way, but that's my plan. Let's do some calculations. So I measured the diameter of a ping pong ball to be 37.37 millimeters. However, my equation for volume of a sphere wants a radius. So the very first thing I'm doing is dividing that diameter by 2 so that I can calculate my radius. So radius equals 18.685 millimeters. Now, it would be much more convenient if this radius was in units of meters, because the density of air that I found is in units of kilograms per meters cubed. So if this is in meters, my units would cancel out nicely later. So I am taking the radius times a conversion factor of 1 meter divided by 1,000 millimeters. So my new radius equals 0.018685 meters. Now I'm ready to use my equation for volume of a sphere. Volume of a sphere, V, is equal to 4/3 times pi times r to the third power, where r is radius. So the volume of my ping pong ball equals 2.732549 times 10 to the minus fifth meters to the third power. And I can convert this volume into a mass by multiplying it by the density of air. So I'm taking the volume of my sphere times the density of air. So the mass of air inside of this ping pong ball is equal to 3.347 times 10 to the minus fifth kilograms. If you want more time to think about the assumptions I've made, pause now, because the next thing I'm going to do is start listing them. Assumption number 1. I assumed that this ping pong ball is a perfect sphere. I only took one diameter measurement. Yes, it looks roughly spherical, but if I really wanted to prove that it was a perfect sphere, I would have needed to take an infinite number of diameter measurements at every single possible orientation. That's an impossible task, but basically, the more diameter measurements I take, the better. I only took one. Assumption number 2. I assumed that this plastic is infinitely thin. It's not. It's here. I can feel it. I can put a little bit of pressure on this ball without crushing it. What I mean is I measured an external diameter. That means my subsequent volume calculation included not just the volume of the air, but the volume of the plastic itself. I would have been better off cutting this ball in half and measuring an internal diameter. Assumption number 3. I assumed that this ping pong ball is not airtight. What I mean by that is I was using a density for atmospheric air. That means that I assumed that the air inside of this ball could interact with the air outside of this ball, and the air everywhere would be the same. Assumption number 4. I assumed that the pressure in this room is 1 atmosphere and that the temperature is 15 degrees Celsius. What I mean by that is the density of air that I looked up is specific for those conditions. If the conditions change, that density changes. I don't have a barometer to measure the air pressure in this room, and I don't feel like telling you weirdos on the internet where I live, but I'm not at sea level, so air pressure is probably lower. And it feels warmer than 15 degrees Celsius in here to me right now. So, people on the internet, this is your time to shine. I want you to tell me what else I did wrong and how I could have done it better. Specifically, list more assumptions that I've made, and tell me how I could redesign this experiment to either compensate for them or completely avoid them. Don't limit yourself to thinking about the way in which I approach this problem. You can completely redesign the experiment. Maybe a better way to measure the volume is to poke a tiny hole in this ball, fill it with water, then measure the volume of that water. Something along those lines. Think outside the box. Tell me how I could have done this in a better way. In science, we never prove anything. The best that we can do is to come up with a model that has not yet conflicted with our observations. The information that you need to get a better answer might not always be available. Maybe your instrumentation isn't good enough. Maybe your understanding of the situation is incomplete. Maybe, in order to collect better data, you need to get to the far reaches of the solar system or the bottom of an ocean, and it's just not feasible. But in order to think like a scientist, you need to acknowledge your assumptions and do your best to limit their impact. Thanks for watching Chemistry in a Nutshell. If you feel that I've earned it, please like this video and subscribe to my channel.